Why solid objects are not solid. What Feynman uncovered will destroy your reality. Right now, as you're reading this, you think you're touching something. Maybe you're holding a phone. Maybe your fingers are on a keyboard. Maybe you're sitting in a chair. You feel the solid contact between your body and these objects. The pressure, the resistance, the undeniable sensation of matter pressing against matter. But here's what's going to ruin your day. You have never, not once in your entire life, actually touched anything. Not really. Every sensation you call touch is an elaborate illusion created by forces acting across empty space. And the thing you think you understand best about reality, that solid objects are solid, is completely, fundamentally, spectacularly wrong. Let me break your brain. Put your hand on a table right now. Press down. Feel that solid surface pushing back against your palm. What you're experiencing feels obvious, doesn't it? Matter touching matter. Solid flesh meeting solid wood. The most basic interaction in the physical world. Except none of that is happening. Your hand is not touching the table. The table is not touching your hand. There's a gap between them. A tiny gap, invisible to your eyes, but a real gap nonetheless. What you're feeling is electromagnetic force, pure force, acting at a distance, through empty space. This isn't philosophy. This is measurable, testable physics. Richard Feynman understood this better than almost anyone. He taught that everything you take for granted about the physical world is stranger than you can imagine. And nowhere is this more true than with solid matter. What makes something solid? You'll probably say atoms are packed closely together. But what makes atoms solid? Why can't you push your hand through a wall? The answer reveals that the fundamental nature of matter is nothing like what your senses tell you. Here's the first shock. Atoms are mostly empty space. Mostly. We're talking about 99.9999% empty space. If an atom were the size of a football stadium, the nucleus would be a pea at the center, and the electrons would be dust specks flying around in the upper seats. Everything in between is nothing. Vacuum. Empty space. Your body, which feels so solid to you, is essentially a cloud of vacuum with tiny specks of matter scattered throughout. You are mostly nothing, sitting on nothing, in a world made mostly of nothing. But wait, it gets worse. Those tiny specks of matter, the protons and neutrons and electrons, aren't really solid either. They're not little billiard balls of stuff. They're probability clouds, quantum mechanical wave functions, mathematical descriptions of where particles might be if you happen to look for them. The more you zoom in on matter, the more it disappears. The more you try to find the solid stuff, the more you realize there isn't any. So if atoms are mostly empty space, and even the parts that aren't empty aren't really solid, why doesn't everything just pass through everything else? Why doesn't your hand sink through the table? Why doesn't the table fall through the floor? Why does the universe appear to have any structure at all? The answer lies in one of the most profound and counterintuitive principles in all of physics: force without contact. The force that creates the illusion of solidity is the electromagnetic force. It acts at a distance, reaching across empty space to push things apart or pull them together. Take two electrons, 1 centimeter apart. The electromagnetic force between them is 10^42 times stronger than gravity. For anything smaller than a mountain, electromagnetic force is the only game that matters. Now, here's the key insight that Feynman hammered into his students over and over again. In normal matter, positive charges and negative charges are mixed together in almost perfect balance. Protons with their positive charge, electrons with their negative charge canceling each other out. The enormous electromagnetic forces are still there, still acting, but they're balanced so precisely that the net effect is zero until you get too close. Then the balance shifts, and those monstrous forces become visible. When you push your hand toward a table, here's what's really happening. The electrons in your hand, those negatively charged clouds of probability, start to overlap with the electrons in the table surface. But electrons hate being near other electrons. They repel each other with tremendous force. The closer they get, the harder they push apart. And because the underlying forces are so enormous, even the tiniest overlap creates a repulsive force you can feel. Your hand stops moving toward the table, not because it hits a solid barrier, but because the electromagnetic repulsion becomes stronger than the force you're applying. The electrons in your skin are literally being pushed away by the electrons in the table surface. You never make contact. There's always a gap, always a space, always a distance across which the electromagnetic force is acting. What you interpret as touching is really being pushed away by invisible forces. This means everything you know about touch is wrong. When you shake hands, your hands never actually touch. When you sit in a chair, you never make contact. When you walk, your feet never touch the ground. You're constantly floating, held up by electromagnetic forces across tiny gaps your senses can't detect. Different materials feel different because their electrons are arranged differently. Steel feels hard because its electrons resist being pushed. Rubber feels soft because its electrons are more loosely bound. The difference between hard and soft, rough and smooth, is all about electromagnetic arrangements. Think about what this means. You've never actually sat on a chair. You've hovered above it. You've never held a book. You've levitated it using electromagnetic forces. Every step has been through empty space, supported by invisible forces. This isn't just a curiosity. This isn't just an interesting fact to impress people at parties. This completely changes how you should think about the nature of reality. The world you experience through your senses is a fiction. A very convincing fiction, but a fiction nonetheless. What you call solid is mostly empty space. What you call contact is action at a distance. What you call matter is mostly force. Feynman loved to point this out because it illustrates something fundamental about how physics works. The things that seem most obvious, most basic, most fundamental to our experience of reality are often the things that are most wrong. Our intuitions evolved to help us survive in a world of medium-sized objects moving at medium speeds. They did not evolve to help us understand the nature of atoms, or the structure of space, or the behavior of electromagnetic fields. When we try to understand the deep structure of reality using common sense, we fail catastrophically. The electromagnetic force that creates the illusion of solidity is the same force that makes chemistry possible. When atoms bond together to form molecules, they're not really touching. They're being held together by electromagnetic attraction between positive and negative charges. When molecules arrange themselves into crystals or liquids or gases, they're not really in contact. They're being organized by electromagnetic forces acting across empty space. All of chemistry, all of biology, all of material science is really just different arrangements of electromagnetic forces acting between charged particles that never actually touch. This has profound implications for how we think about ourselves. Your body is held together, not by some kind of biological glue, not by physical contact between parts, but by electromagnetic forces. Your cells are electromagnetic structures. Your DNA is an electromagnetic pattern. Your thoughts are electromagnetic signals moving through electromagnetic networks in your brain. You are not a solid object in any meaningful sense. You are a dynamic pattern of electromagnetic activity, constantly changing, constantly shifting, constantly recreating itself. from moment to moment. But there's another force, the Pauli exclusion principle. This quantum rule states that no two electrons can occupy the same state. It's not about force. The universe simply forbids it. When you push atoms together, quantum mechanics says no. The wall resists because reality has rules about what can exist where. The boundaries between objects aren't real. They're just places where electromagnetic patterns change, where the pattern you call yourself meets patterns you call environment. Your body's edge isn't a real boundary. It's where your electromagnetic pattern fades into others. You might be wondering how we can build buildings and bridges and machines if nothing is really solid, if everything is just electromagnetic forces acting across empty space. The answer is that those forces are incredibly strong and incredibly reliable. The fact that matter is mostly empty space held together by forces doesn't make it weak. It makes it incredibly strong. Diamond, one of the hardest substances known, is just carbon atoms held together by electromagnetic forces. Steel, concrete, granite, all just different arrangements of electromagnetic interactions. The emptiness doesn't make them fragile. The forces make them nearly indestructible. But here's the truly disturbing part. If matter is mostly empty space, and if the forces holding it together are acting at a distance, then why does matter have any definite shape or size at all? Why doesn't it just collapse into a point or expand to fill the universe? The answer takes us into the deepest waters of quantum mechanics, to a place where common sense not only fails, but becomes actively misleading. The size and shape of atoms are determined by a balance between attractive and repulsive forces, but also by something called the uncertainty principle. Electrons can't be precisely located. The more precisely you try to confine an electron to a small space, the more energy it has, the more it wants to escape. So atoms find an equilibrium size, where the attractive forces pulling electrons toward the nucleus are balanced by the quantum mechanical pressure pushing them outward. The size of an atom is not determined by the size of its parts, but by the balance between forces and quantum uncertainty. This means that the size of your body, the dimensions of the room you're sitting in, the scale of everything you can see and touch, are all determined by quantum mechanical principles operating at the atomic level. The macroscopic world gets its structure from microscopic quantum effects. The familiar emerges from the bizarre. The solid emerges from the empty. Now, let's think about what this means for our understanding of the universe. We've discovered that solid objects aren't solid, that touching doesn't involve contact, that matter is mostly empty space held together by forces acting at a distance. But this isn't just true for exotic materials in physics laboratories. This is true for everything. The chair you're sitting in, the ground beneath your feet, your own body. Everything is mostly nothing, held together by invisible forces, maintaining its apparent solidity through quantum mechanical principles that defy common sense. Feynman used to love pointing out that once you understand the electromagnetic nature of matter, a lot of things that seemed mysterious become obvious. Why can't you walk through walls? Electromagnetic repulsion. Why do objects have weight? Electromagnetic forces holding atoms together against gravitational attraction. Why does matter have different properties? Different arrangements of electromagnetic interactions. Why does chemistry work the way it does? Electromagnetic forces between electrons and nuclei. Almost everything about the physical world can be traced back to electromagnetic forces acting between charged particles that never actually touch. But this raises another disturbing question. If your sense of touch is just electromagnetic repulsion, if solid matter is just force fields in empty space, then what about your other senses? Are they telling you the truth about reality? Or are they also elaborate illusions created by physical processes you don't understand? The answer is not comforting. Take vision. You think you see objects because light bounces off them and enters your eyes. But light isn't really bouncing off anything. Light is electromagnetic radiation, and when it interacts with matter, it's really interacting with the electrons in the atoms. The electrons absorb the electromagnetic energy, get excited to higher energy levels, then release the energy as new photons. What you call seeing an object is really detecting electromagnetic radiation that has been absorbed and re-emitted by the electromagnetic patterns you call matter. You're not seeing the objects themselves. You're seeing electromagnetic echoes. Sound works the same way. You think you hear objects making noise, but what you're really detecting is pressure waves in air molecules. And air molecules are just more patterns of electromagnetic activity, more arrangements of atoms held together by electromagnetic forces. The vibrations you call sound are electromagnetic patterns pushing against other electromagnetic patterns, creating waves of compression and rarefaction that your ear interprets as noise. You're not hearing objects, you're detecting electromagnetic activity. Even smell and taste are electromagnetic. The molecules that create odors and flavors are specific arrangements of atoms held together by electromagnetic forces. When these molecules reach your nose or tongue, they interact electromagnetically with receptor molecules, triggering signals that your brain interprets as smells and tastes. Every sensation you've ever experienced is really just your nervous system detecting different patterns of electromagnetic activity. This brings us to the most disturbing conclusion of all. Your entire sensory experience of reality is an electromagnetic hallucination. Everything you see, hear, touch, smell, and taste is just your brain's interpretation of electromagnetic interactions between particles that never actually come into contact. The solid world of your experience is a fiction created by electromagnetic forces acting across empty space. You don't live in a world of objects. You live in a world of forces. But here's what makes this revelation both beautiful and terrible. The fact that matter is mostly empty space, held together by forces, doesn't make it less real. It makes it more miraculous. The fact that you can walk on apparently solid ground, even though you're really levitating above electromagnetic force fields, doesn't make walking less impressive. It makes it more amazing. The fact that you can hold objects, even though you're really manipulating electromagnetic patterns through action at a distance, doesn't make manipulation less useful. It makes it more elegant. The universe has created the illusion of solidity so convincing that it took thousands of years of scientific investigation to see through it. The electromagnetic forces are so perfectly balanced, so precisely tuned, so exquisitely coordinated that they create stable structures that persist for billions of years. Your body maintains its apparent solidity for decades. Buildings stand for centuries. Mountains endure for millions of years. All held together by nothing but electromagnetic forces acting across empty space. Feynman understood that this wasn't a bug in the design of the universe. This was a feature. The fact that empty space and invisible forces could create the appearance of solid matter wasn't a cosmic joke. It was a demonstration of the incredible power and elegance of natural law. Simple rules operating at the most fundamental level, creating infinite complexity and beauty at larger scales. The familiar world emerging from unfamiliar principles. Order arising from apparent chaos. Think about what this means for your daily life. Every time you pick up a coffee cup, you're performing an electromagnetic miracle. You're using electromagnetic forces generated by electromagnetic patterns in your brain to control electromagnetic structures in your muscles to manipulate electromagnetic fields around your fingers, to lift an electromagnetic pattern that you perceive as a solid object. And all of this happens across gaps of empty space, using forces acting at a distance, without any actual contact between any of the components. The spoon you use to stir your coffee never actually touches the coffee. The coffee never actually touches your tongue. Your tongue never actually touches the roof of your mouth when you swallow. Every part of this everyday activity is electromagnetic forces acting across empty space, creating the elaborate illusion of solid objects interacting through contact. And your brain, that electromagnetic pattern interpreting electromagnetic signals, creates the convincing fiction that you're dealing with solid matter in a solid world. But here's the most profound implication of all this. If matter is really just patterns of electromagnetic activity, if solid objects are just stable arrangements of forces in empty space, then the boundary between matter and energy becomes meaningless. Matter is energy. Energy is matter. They're not two different things. They're two different aspects of the same underlying reality. This is what Einstein meant when he wrote E=mc2. Matter and energy are interchangeable. You can turn matter into energy. You can turn energy into matter, because they're really the same thing. This means that you, sitting there reading this, are not made of solid stuff that's separate from energy. You are energy. You are a dynamic, ever-changing pattern of electromagnetic activity that maintains its structure through constant interaction with the electromagnetic patterns around you. You are not a thing. You are a process, not a noun, but a verb, not a static object, but a dynamic system, not matter, but organized energy pretending to be matter. The chair you think you're sitting on is also energy. The air you're breathing is energy. The light you're seeing is obviously energy, but so is everything the light is bouncing off of. The entire universe